We're going to compute this integral by using u-substitution method. So the first thing we want to do is we want to pick out a u that's going to make this more simplified, something that we know how to integrate. And in this case, what we want to do is we want to pick out u to be this entire denominator. So 9x squared plus 16x plus 7. Then what we do is we differentiate. So we take the derivative of the left side, we'll get a du. Derivative of the right side, we're going to get, using the power rule, 18x plus 16. And with that, we also include a dx. Now, from the original problem, you may notice we have a 9x plus 8 up in the numerator. What we could do is we could rewrite that, kind of moving it off to the side. So I'm going to keep the same denominator here. And why I'm rewriting this is just so you can kind of see exactly where my thought process is coming from. If we wanted to, we could put that back together and it would look just like our original once again. But you'll notice that what I have in red over there, the 9x plus 8 quantity multiplied by dx, we don't quite have that in red on the left-hand side. But we can get there by simply doing a little bit of factoring. We have a 2 in common. You may notice between the 18x plus 16. If we factor out that 2, that'll leave us with 9x plus 8 and a dx. Notice we have 9x plus 8 in parentheses with the dx. Well, we'd like that to be on one side all by itself, so we can move the 2 to the other side by dividing by 2 or multiplying by 1/2, is a lot of times how I visualize it. All right, by isolating that quantity 9x plus 8 with the dx on the outside, now we're going to be able to simplify and fill in, substitute that into our problem. So with our substituting, our denominator is going to become a u. Our numerator, I'm going to say, is still a 1, as it was written up above. Now, for the 9x plus 8 dx, I'm going to put a 1/2 and a du into this problem. Now, because the 1/2 was a fraction, because it was a constant, I'm putting it out in front of the integral, because constants just kind of come along. All right, from here, we want to integrate, so the 1/2 will come along. The antiderivative of 1 over u is the natural log of the absolute value of u. And we also want to include in our problem a plus c to represent some constant that can be added. Now, to finish this up, all we have to do is we want to get back to x's. Right now, we kind of made up u at the beginning of this problem. We want to get u out of there and get x back involved. So where u was, what we're going to do is go back to that original statement where we said u was equal to 9x squared plus 16x plus 7 and fill back in. And that's our antiderivative. So I hope this helps out as you're working on u-substitution and taking antiderivatives. Good luck.